Hello students, in today's class we are going to learn about design technology. After the end of the class, we will be able to understand what is design technology, steps followed by the design technology, and there are many approaches to improve the design process for increased productivity. Let's start from design technology. Design technology involves the manner in which we convert our concept of desired system functionality into an implementation. We must not only design the implementation to optimize design metrics, but we must do so quickly. The designer must be able to produce larger number of transistors every year to keep pace with IC technology. Improving design technology to enhance productivity has been focused on of the software and hardware design communities for decades. IC design steps are shown in the given diagram. Specification, then high level description to functional description to logic description to gate level description, finally placed a router design. Proper design methodology helps to manage the design process and improves quality, performance, and design cost. A sequence of design steps. In a design methodology, the design flow can be partially or fully automated. A set or tools can be used to automate the methodology steps. First step is software. Software engineering tools. Second is compiler. Third is computer aided design tools. Computer aided design tools, etc. Through specification is converted to high level description. This high level description is behavioral, VSDL, or C languages. In high level description, behavioral is B. Behavioral is the describe the function of a circuit regardless of its implementation. Now this one is the functional description. Functional description means structural VHDL. Now in functional description, structural description as an interconnection of components. Now, functional description to logic description function is called synthesis. This logic description contains the logical expression Now logic description to get level description is the technology mapping. Now this process is the mapping process. In get level description, logical description of get is fabricated on the ICs. Now get level description design to placed and routed design is the physical design. Physical design relate to the physical object, for example transistor of a design. This get level design is mapped or placed a routed design into a wafer. Wafer is a disk of a pure silicon. After cutting down, it will shown in this structure like IC. This is called the integrated circuit. This get level is fabricated on this wafer and from this wafer IC is cutting down, then it will look like a integrated circuit. To understand how to improve the design process, we must first understand the design process itself. Variation of top down design, top down design process have become popular in the past decade. After navigating through a number of abstraction levels, this system is polished and refined. Now, what is abstraction? A model of a circuit is an abstraction. This is the representation that shows relevant features without associated details. This one is the circuit model in few details, which is synthesized and give the circuit model in many details. This is the abstraction or model of a circuit. The designer at the system level explains the desired functionality in a particular language, a natural medium like English, or in a preferred language like C, and this is labeled as specification. This specification is refined by the designer by diffusing parts of it among selected processor, that is general or single purpose, and resulting in behavioral specification for each processor. This one. The designer refines this specification into register transfer, that is RT specification, by converting behavior on general purpose processor to assembly code, and by converting behavior on single purpose processor to a connection of register transfer, components and state machine. this one. Subsequently, the designer then perfects the register transfer level specification of a single purpose processor into a logic specification which is made up of Boolean equation. Finally, the designer refines the remaining specification into an implementation consisting of machine code for general purpose processor and a get level netlist for single purpose processor. How design productivity exponential increases over the past few decades. From here is the comparison between the 1981 to 2009, how it increases over the first few decades is shown in this graph. The two technology, that is processor and IC technology, are independent. To understand how to improve the design process, we must first understand the design process itself. Variation of a top-down design process have become popular in the past decade. An ideal form which is discussed with respect to processor technology or IC technology have discussed in IC technology steps. The co-design ladder. In the past decade, hardware and software design technology were very different. Recent maturation of synthesis enables an unified view of hardware and software. There are three main approaches to improving the design process for increased productivity, which is labeled as compilation, or synthesis or synthesize. Libraries or IP. Third one is the test or verification. Let's discuss compilation and synthesis. In compilation and synthesis, a designer specifies desired functionality in an abstract manner and automatically generates lower level implementation details, describing a system at high abstraction, that is the model of a circuit level, can improve productivity by reducing the amount of details, often by an order of magnitude, that a design must specify. A logic synthesis tools convert Boolean expression into a connection of logic gate. Boolean expression into a logic gate called a net list. Boolean expression into a logic gate is called net list. A register transfer, that is RT, synthesis tool, this one, this is done, logic synthesis, now RT synthesis. A register transfer or RT synthesis tool convert finite state machine and register transfer into a data path of RT components and a controller of Boolean equation. A behavioral synthesis tool convert a sequential program into a finite state machine and register transfer. Similarly, a software compiler convert a sequential program to assembly code, which is essentially register transfer code. Finally, a system synthesis tool convert an abstract system specification into a set of sequential programs on general and single purpose processor. Design for the former is commonly known as hardware design and design for the latter as software design. Earlier design processes were drastically different. Writing sequential program was the software designer domain, whereas hardware designers were concerned with connecting components. However, the hardware design process, having been converted by synthesis tool, is now into writing sequential program. Now discuss second one, that is libraries or IP. Libraries are meant for the reuse of pre-existing implementation. When these libraries are used, it results in the enhancement of productivity, as here one can take time to find, acquire, integrate and test a library item, which is much less than time taken to design the item. First one is the layout for gates and cells appear in the logic level library. Second is layout for RT components like register, multiplexer, decoder and functional unit appear in the RT level library. Third is the frequently used components such as compressor component, display controller and even general purpose processor are found in behavioral level library. This is the layout for gates and cells of a logic level library. Now, components are no longer just ICs but are available as a form labeled as codes that can be implemented on just one part of an IC. This change from behavioral level libraries of ICs to libraries of course has prompted use of the term intellectual property, that is IP, to emphasize the fact that course exists in a soft form that must be protected from copying. Finally, a system level library might consist of complete system solving particular problem such as an interconnection of processor with accompanying operating systems and programs to implement an interface to the internet over an Ethernet network. Third one is the test or verification. Test or verification involves ensuring that functionality is correct. Such assertion can prevent time consuming debugging at low abstraction level and iterating back to high abstraction level. The usual process of testing the correctness of functionality is simulation, but other formal authentication methods are also getting accepted. For example, at different level verification is done. First one is the logic level. Get level simulator provide output signal timing waveform given input signal waveform. General purpose processor simulator perform machine code. And RT level hardware description, that is HDL, simulator carry out RT level description and give output waveform when provided input waveform. The behavioral level hardware description level HDL simulator simulates sequential programs and co-simulator connect HDL and general purpose processor simulator to ensure hardware software co-verification. Well, a model simulator the initial specification making use of an abstract computation model which is not dependent on processor technology to attest accuracy and completeness of the specification. Design productivity gap. While designer productivity has grown at an impressive rate over the past decades, the rate of improvement has not kept pace with the chip capacity. Approaches to improving designer productivity. Standard focus on developing well defined methods for specification, synthesis, and libraries. Such standard can reduce the problem that arise when a designer uses multiple tools or retrieves or provide design information from or to the other designers. Common standard includes language standards, synthesis standard, and library standards. The given graph shows the logic transistor per chip in million over the productivity. In 1981, leading edge chip required 100 designer months, that is 10,000 100 transistor per month. In 2002, leading edge chip requires 3,000 designer months, 15 crore and 5,000 transistors per month. Designer cost increases from 1 million to 300 million. The situation is even worse than the productivity gap indicates. In theory, adding designer to team reduces project completion time. In reality, productivity per designer decreases due to complexities of team management and communication. In the software community known as the mythical man month, that is Brooks, in 1975, at some point can actually lengthen project completion time, that is too many cooks. Too many cooks. One million transistor, one designer required, that is equal to 5,000 transistor per month. Each additional designer reduces for 100 transistor per month. So 2 designer produces 4,900 transistor per month each. Thank you.